Hello and welcome back to episode 3 of our KoiLoader malware analysis series. This time we're going to be looking at this script here in particular and this one-liner, because this value, as a spoiler, is used in this script. We're going to save this one here, this Zeet one, for the next episode. So to have a look at this, well, let's first of all have a quick look at what this is doing if we recap. So it's setting ff set value to be null, comma, and then it evaluates as true if this value here, this string, or if this string, contains this string, which it does. So this will be set to ff equals null, comma, true, and that's all we need to know for now. So if we look at, well, if we first go to URL scan, this is what is pulled. It is fairly simple looking, not too much going on here. However, if you unpack it, it does turn out to be quite interesting. So let's do that now. So I've downloaded it and added comments, which you can read at your own leisure. But let's walk through each line one by one and explain what it's doing. So first of all, it's setting the value A to be an array of assembly get types. So the assembly in this case is like a .NET assembly, and the assembly in this case is PowerShell. So PowerShell get types. So if we run this, just for a demonstration, and then print out A, it is all the types used by PowerShell. So these are the types, and then these are like the items. I'm not sure what the correct term is off the top of my head. If you just scroll to the top, it should say just the name and then the type. So it's trying to find something in this long list of names and potentially the type related to it. So what we want to do is, the name is like SIUtils, so it's iterating through this list, and then it's trying to find the value where B, where name is like SIUtils. So it's just trying to find a specific name within that list, to put it more simply. So just clear that. If I run that next one and then print out B, and then so that is the last one in the list, and then C, which is the one that it wanted, it evaluated to true. If this if statement is true, if this is this, so this is one it was actually looking for. So it's looking for something to do with AMSI. So what is AMSI before we get any further? If we have a look at AMSI, is defined by Microsoft themselves as the Windows Anti-Malware Scan Interface. So without reading this out line by line, it's essentially an API which can be used within Windows, and any malware vendor can use it to hook into scripts essentially. So things like JavaScript running, Office VBA macros, or PowerShell in this case, can integrate with AMSI, and then what's being ran can be checked by a malware vendor. So Defender, for example, can check what is running within a PowerShell shell. So it's a fairly, it's a tool that you don't want to be disabled. You want to make sure it's running, and we might see in the next step that it is disabled, or it's tried to be disabled. Whether it's successful or not will be dependent on the environment. But this anti-malware scan interface is kind of like an integral part of the ability for anti-malware products to scan, essentially. So if we go back to here, so we've defined C is AMSI. So now we want to set D to within AMSI get fields non-public static. So if I just run that next one in PowerShell, let me see what it spits out, and it is doing that thing where it doesn't want to take copy paste, I think. Oh, there we go. And then let's have a look at D. So this is get fields for AMSI context, AMSI session, AMSI init failed for all these names, and then AMSI lockout. So it's pulled out all of those, and then the final the final iteration through a loop for this for each is looking for E and D, and then again it's doing a similar if statement where if the name is like failed, then it's setting E to FF. Now remember, FF from before was defined as null, comma, true. So we can just run this bit here because we don't want to actually set anything. If we just go onto here, copy this in, and then we can just do this for D. And then it is AMSI init failed. So what could this be? It's likely some sort of AMSI bypass. So if we have a look at different AMSI bypasses, we can probably find one that matches. And spoiler alert, we have one here from Matt Graeber. I think that's pronounced Matt Graeber, from 2016, quite a while back. And what we're seeing is pretty much exactly the same as this, except what we've seen in our script is a obfuscated version. So rather than call to system management automation AMSI utils directly, it is iterated through to find this and then pass that into a variable. This is essentially just trying to prevent detection content from picking up on this. And ultimately, it's setting this AMSI init failed object to null true, which bypasses in AMSI. So it's essentially setting this to null. So AMSI isn't going to be initialized within the context of that PowerShell session. There's some more explanations here. So this is very similar to the one we saw, this command. Seeing this similar iteration. The main difference here is it's being defined as null, comma, true here, whereas when we saw it, it was using that contains from the other PowerShell, the previous script. And then finally, we've got kind of a bit of an explanation of how it works. So it's saying this bypass is assigning init failed as Boolean true. So AMSI initialization fails. So no scan will be done for the current process. Obviously, if PowerShell's restarted, it's only within the context of this PowerShell session. So it would no longer be set. But obviously, anything that's executed after this, if this AMSI bypass is successful, will not be hooked by the AMSI process or by the AMSI API, and then the malware tools will just be blind to whatever's happening within that PowerShell window. So that's pretty much what we've seen. If we just go back to here, we can have a look at different detection content we could build. So this AMSI assembly get types we saw at the beginning, it's kind of strange for things to, for PowerShell to be running get types. Suspicious, I wouldn't say it's malicious. Then name like SI utils, the only example that comes up is for malware. So if you just run a search for this, it's for this AMSI bypass. Not many examples, but there's potentially a few others, but it seems to be mainly, if I actually quote the whole thing and get better searches, Pentest Party, Breach Forums, GitHub. So this is all, if you run a better search, this is all related to the AMSI bypass. So that would be a good piece of detection content. Similarly, name like failed. Again, if we just run a quick search for that in Google. Okay, this is getting up a lot of false positives, but it's still finding some of the Pen 300. I think that's a it's OSIP, so it's penetration testing course exam you can do. So it's coming up with less examples, but I'm pretty sure in your environment you're going to see good hits for that. And then this null true, potentially this might be a bit weak, but these two are definitely would be decent bits of detection content you may want to create in order to catch this. So hopefully that was elusive for you. I think next video will be maybe a bit lengthy because it's going to be hopefully looking at kind of the actual payload itself, the maliciousness, which will be dropping an executable. I'll catch you next time, I presume. Maybe not. Who knows? Whatever. Bye.